Release system is armed.
Vehicle is transitioned to autonomous mode. We are go for launch. 3, 2, 1. Ascent operations will continue on CD1.
T+1 minute. Max Q.
We go. Stage separation.
Bearing separation confirmed.
All right, folks, welcome to the Firefly Aerospace stream this evening. We are currently T-minus 30 minutes away from Flight 5 of Firefly's Alpha rocket. It's coming out of Vandenberg Space Force Base this evening, as you can see on the screen right there. You can also see a little bit of the rocket next to it. It's Vandenberg. It might be foggy, but whichever way it works, we're going to show you what we see. The launch is scheduled tonight for 9:03 p.m. Pacific time, and the mission name is The Noise of Summer. My name is John Galloway. I'm with NSF. NASA Spaceflight's providing live stream services for Firefly this evening as we cover this. But if you've seen one of our shows before, you know the drill. I like to surround myself with people who know. Evening, I have Morgan Fiane with me here from Firefly Aerospace, who is a composite structure engineer. Morgan, how you doing this evening?
I'm good. I'm ready to see this thing fly.
Ready to see this thing fly. Tell us a little bit more about yourself. Like, what do you do at Firefly?
Yeah, so I am a primary structures responsible engineer. So what that means is that I'm responsible for a large part of Alpha and our new development vehicle, our medium class launch vehicle, kind of the main skeletal structure of the rocket. If you see Alpha on the pad there, I have touched every part of that thing in some way, shape, or form, be it through redesign or testing or inspections or being the POC for manufacturing.
Outstanding. So this evening we'll get a little bit of insights from a structural engineer who's worked specifically on these rockets here, y'all. Now, a couple different things are going on this evening. We're launching, I think, 8 payloads, right?
Yeah, we're launching 8 payloads as a part of our VCLS contract with NASA. And I have sold my soul to space and all of its acronyms, so VCLS stands for Venture Class Launch Services. Please stop me if I say an acronym and I don't explain it.
It's good. I'll jump right in like, wait, what?
Yeah, wait, what did you say? But yeah, these 8 payloads were selected through NASA's CubeSat launch initiative, and it's kind of an attempt to give educational institutions and nonprofits a low-cost access to space.
I like it. A very worthy cause, getting some additional access to space for institutions that might not normally be able to afford it. It's expensive to go to space.
Yeah, it really is.
All right. We're going to be talking a little bit more about that in just a bit, y'all. We've got a lot of different stuff to share with you here as we continue the count. It's just ticked under, where are we at, 28 minutes, it looks like? So let's continue on. Now, this evening, we're deploying some payloads, but they're not going sort of a transfer or anything.
Our stage 2 engine for 6 or so minutes like that, and it'll put us into a direct injection orbit. So we're putting these payloads exactly where they're going to be performing their science.
Gotcha. And right now, I think the last update we have on weather is that the weather was looking good, right?
Yeah, I know it looks foggy out there, but that is a green for launch at the moment. So I don't know how much we'll be able to see, but we will be able to launch.
We have all sorts of different cameras to share with you. We've got pad cameras and flame trench cameras and engine cameras. There's even some cameras on the vehicle that we'll be expecting to show you as well. But bear with us. It is tough over there on the Vandenberg. So I'm putting past you to the rocket.
Putting past me. Okay.
There is a rocket over there on the other side. But welcome to Vandenberg live streams, folks. 9:03 p.m., coming up rapidly here. A lot of people hopefully will not be under the fog and be able to look out for this launch. Which way should they be looking? Like, will they be able to see it? What might they see?
Yeah, so there's a good chance that people across the Southwest can see the launch. I know it's foggy, but at least I've been told that we can see something called the twilight effect above the fog. So that's when you see not necessarily the rocket, but the rocket's exhaust plume when it's illuminated by the setting sun in the upper atmosphere.
Gotcha. It's that situation where it's dark on the ground because the sun has set for you, but here we have a graphic sort of showing which way you should look out here. So on the map, There's Vandenberg in the middle. The count is showing you T+ after the rocket has launched. And if you're over there in LA, you'll be looking out to the west. San Francisco, look down to the southwest. See if you can see it. San Diego might get a show. Once we get over into the west, like Salt Lake City, Las Vegas, Portland's way up there. You know something? What do you have to lose? Like when you see the launch occur, step outside, see if you've got clouds above you, see if you can't see this happening, because if the sun illuminates this plume, it's going to be quite a show.
Yeah, it'll look beautiful. I think I've heard you call it the jellyfish
effect. Yeah, the jellyfish effect. So if you see it, hey, snap a picture of it. Get out your phone. Put it up on social media. If you do, tag us, Firefly_space, if you're on x.com. And we'd love to see how you experience the launch from wherever you're watching from this evening. There it is right on the screen at Firefly_space. Also, over the course of the broadcast, we're going to be looking for some audience questions. So if you're watching on the YouTube channel, tag us there at Firefly Space. And when we get some chances, we will see if we can't answer some of your questions. So tonight's mission is demonstrating Firefly's rapid launch operations. Why does Firefly keep offering this sort of rapid turnaround as a service?
Yeah, so it was all kickstarted by our third flight, which was a mission called Victus Nox for the Space Force. So what happened there was we got a phone call. We didn't know what day the phone call was coming.
Right.
And basically they said, okay, you've got 24 hours to prep your rocket for launch. So when we did that, I think one of the biggest takeaways we had was that there is a huge benefit to our customers, all of our customers, for providing this kind of 24-hour launch window, because satellite technology moves really quickly, and as simple as that, there could be a huge benefit on eliminating a lot of that wait time if your satellite's not sitting on a shelf for 2 years.
Gotcha. So instead of, normally you might schedule this months in advance or weeks in advance, this is the payload's there, like Firefly has the payload, but you don't know when you might need to launch it. And this is, they call you up, they say, hey, all right, we're ready to go. Let's get it encapsulated and send it.
Yeah, so it's. I'm not going to say that we're going to offer Victus Nox conditions.
Fair enough.
Please don't call us randomly and say, "Hey, you have a day."
Like, hey, I'm outside right now with a payload. Like, can you launch
where are
it?
you guys? Yeah, no. This is a case where we'd agree on a launch date, but we would encapsulate your payload and send it up within 24 hours.
Within 24 hours of the call.
Yes.
All right. And the team has done a lot of work to sort of streamline these operations to go from payload sort of in the payload facility to on top of the rocket and on its way to space. Let's talk a little bit about what the team's been accomplishing here to get ready for this.
Yeah, we rapidly accelerated all of these operation times in order to do this in 24 hours. And there have been a ton of things happening in the last 24 hours to prep this rocket to go up there. So even in the last 18 hours, we've done final payload checkouts. We've encapsulated those payloads in the fairing, and we'll transport that whole fairing payload stack to a horizontal alpha from the PPF, payload processing facility. There we go. Yeah. So we'll wheel it out from there to the pad. We will mount it to alpha horizontally, and then we'll raise alpha up, and we'll start configuring the pad for flight at T-9 hours.
T-9 hours. All right. So you're on the pad. I mean, this picture clearly shows payloads on top of the rocket there. But what do we have to do after we've configured the pad for flight?
Yeah, we'll start stage 1 fuel load. We'll begin LOX load, stage 2 fuel load. Really, we're just dumping propellants into this thing. But in total, it's...
In a very controlled manner.
In a very controlled manner.
Right.
I say dumping. That's probably not the right word there. But yeah, there's something like 3,000 plus individual manual steps and 50 plus automation sequences, all in a matter of hours. So it's a stupid amount of work to do in a day, but we get it done.
Good deal. And you say automation steps, like even one automation step may kick off a lot of steps, like sub-steps. I don't know if that's the right terminology.
Yeah, like health checks, all that kind of stuff.
Yeah. So a lot of work going into getting the payload out of the facility. One of the things we saw online is, what is this? What's the deal with the payload fairing? Who cares about it? Well, we put the payload fairing, or the payload in the fairing inside the sort of clean, controlled environment. And then when it gets transported from that environment to the pad, it's in the fairing. It's encapsulated, so it's protected. Yeah,
exactly. I mean, you can see by how foggy it is out there. Vandenberg is a very kind of moist, humid climate.
Yep.
And these payloads don't like super humid. They also don't like super dry. You can have arcing in your electronics. They don't like too hot. They don't like too cold. They're very, very picky.
It's like the Goldilocks for payloads.
It is the Goldilocks. So we kind of keep those conditions in the PPF, and then the fairing has something called ECS, which is an environmental control system, and that will take care of the payloads happens when it's on the rocket.
Gotcha.
You need to raise
So,
concerns,
folks,
please hail the launch director
coming up.
CD1, otherwise the conversation
Oh,
will
we're
take
listening
place
in
on
actually.
LVN
Let's
or
see here.
LVNet as appropriate. In the event of an abort, the protocol is to call abort, abort, abort on CD1. A hold is called by range support personnel. The launch director will call abort. The vehicle controller will abort the auto sequence. In the event of a hang fire, the launch director can make the call. The LD will announce DC hang fire abort on CD1. The vehicle controller will then use hang fire abort button on the autos page. The hang fire is called. The vehicle controller will transition the flight computer into emergency shutdown through a direct vehicle state update in the GUI. This launch conductor and countdown net with a ready report for terminal count. RC, go. FSW,
Go.
GSW,
Go.
GNC,
Go.
Prop 1,
Go.
Fluids 1,
Go.
Structures,
Go.
AVI,
Go.
FTS,
Go.
GC,
Go.
BC,
Go.
Payload,
Payload is go.
Mission Manager,
Go.
ELWO,
Go.
FISBO,
Go.
IFCO,
Go.
OSM,
Go.
ROC,
Go.
Safety Official,
Go.
Chief Engineer,
C is go for terminal count.
Launch Director,
Go.
LDA. Copy, we are clear for terminal count.
That was a lot of goes.
That was a lot of goes. That was a board of green.
That is exactly what we wanted to see. Y'all heard it, folks. Across the board, everything green for the launch. Now coming up in less than 19 minutes. Alpha is go for launch. Morgan, tell us a little bit more about the configuration of Alpha. Like, how many stages of it? I mean, you helped build it.
I did. So Alpha is a 2-stage rocket that can carry about 1,000 kilograms to LEO. And what that means is that we are propelled by 4 Reaver engines on our first stage, and we're propelled by 1 Lightning engine on our second stage. All these engines are tap-off cycle. They're designed and built and tested, manufactured, everything in-house at our Briggs facility in Texas. So we strap those on and we send the thing to space. Alpha is the largest small-class launch vehicle. And part of the reason we're able to do this is because the structure is made out of carbon fiber composites.
Gotcha. That's where you come in.
That is my bread and butter. Yeah.
All right. So a lot of different things going on. Y'all can see on the screen there the way that Alpha is actually put together with the 2 stages.
Yeah.
Let's talk a little bit more about your bread and butter, the carbon fiber composites.
Sure. Say less.
Say less.
Yes, carbon fiber. The reason, again, we can carry that much mass is because carbon fiber is incredibly strong and it's incredibly lightweight. And that means that we can lift heavier payloads at a lower cost. So more of the rocket mass can be put towards payloads or propellant.
Gotcha. So that's where like less of the rocket is rocket, leaving more payload or mass, I guess, for the payloads. Fuel, you can add some more propellant, get some more performance out of it. I love this, by the way. We were prepared just in case it was totally foggy out there at Vandenberg, so we have a stand-in rocket where we can show you what you would be seeing if we were not at Vandenberg on the West Coast with that marine layer creeping in there. But that really is what it comes down to. Using the carbon composites reduces the mass of the structures, which gives you more performance, more ability to carry payload, which we're going to talk a little bit more about in a second. Oh, look at this. We have all sorts of cool tricks this evening. So these fueling graphs, or the fuel numbers here, are actually coming off live telemetry. If y'all watch it, if they come up again, watch to see some of those LOX numbers go to 99, 98 as they actually top off and replenish those tanks. This is coming from live telemetry. The Firefly team that built the overlays has done a fantastic job giving us cool stuff to show on the live streams, especially with the fact that, you know, there's a little fog out there. It happens.
Yeah, I wish you could see the ice bands around the cryo tanks. They're very fun to see.
We'll have to animate that next time.
Yeah,
we
you gotta,
show you
where are my ice bands, John?
They're there, trust us, on the rocket as we continue the count here. Now, you said a couple other things. There's 4 engines down on the bottom, like 4 Reaver engines that Firefly designed and built. Up on top, there's one, or up top, sort of in the middle, there's one Lightning engine.
I hope it's not on top.
It's not on top.
Yeah, that's our Lightning engine in the middle. So that one's designed to operate in the vacuum of space.
Gotcha. So some optimized for taking off from the ground, and some optimized for operating up in the vacuum, like you said.
Exactly. And I don't love talking about engines, but I do love talking about structures.
Structures.
And this is a perfect segue to show off the prop that I brought. This is what I do. Very easy to sum up in a little small coupon like this.
Visual aid.
A little visual aid. So our structures are, we call them sandwich laminates.
Right.
Kind of looks like this, like a little ice cream sandwich.
Yeah, sandwich. It's even got the colors right and the ice cream in the middle.
Exactly.
Probably
yeah.
shouldn't eat that.
Yeah, please don't eat this. So the outer layers are carbon fiber, and then the inner layer is a foam core. And this is just a test coupon, so this isn't directly representative of what's flying today.
Yep.
But yeah, I wanted to show off a little bit of what our rocket looks like, a little section.
Excellent. It really is the coolest thing, like when we can bring something. There's actually more stuff down here that you'll see later.
It's secret.
When we can
Don't
bring
tell
in
them.
something to show you. I want them to keep watching, so we want to tell them.
Keep up the intrigue.
About the other things behind the table. Hey, we are now less than 14 minutes away from launch. Things are going to start happening faster. We're going to talk about some of them in advance here. Walk us through what's going to be happening next.
Yeah, so we're going to execute about 300 or more commands and health checks. Right now we're kicking that off with stage 1 engine chill. So what we're doing there is we're pulling locks through our LOX pumps on our stage 1 reavers, and the intention is to chill those pumps down to where we're not going to surprise the engine by putting
the engine.
Yeah, it's a relatively comparatively hot pump. When you put cryo fluid on it, it'll flash the cryo fluid. We don't want that. That can cause cavitation and all kinds of other nasty stuff. So yeah, we're chilling in our engines now. That takes about 15 minutes. So that's why that's kind of one of the first things we start. At T-minus 13, so starting in about a minute here, you might see those engines on camera start to wiggle. What that is the TVC systems kind of doing some health checks, making sure they're moving.
The thrust vector control.
That is right,
I
yes.
had to jump in.
Yeah, you had to jump in. That's fine. Yeah, so what we're looking for there is not only that they move because they should be moving, but that they're moving smoothly. And if they are not moving smoothly, if they're stuttering, that's an indication that the servo valves have ingested some gas.
Okay.
Yeah, not good. We would need to actively bleed that out.
Gotcha. So it's not just about whether or not the engines are moving. They're vectoring their thrust to give you some attitude control over the rocket. It's how smoothly they're moving. And I imagine there's a graph that's going to show this as well, like the smoothness of the move. But just seeing those TVC checkouts is another important step.
Yeah, we call them TVC wiggles.
TVC wiggles.
Very technical term. So yeah, you'll see those engines wiggle pretty soon probably. We'll prep our TTEB system, which is our igniter.
Yep.
Very conveniently for us, it burns green. So we can use that in all our promotional material.
That's a whole thing. It matches the logo.
It does, it does. We definitely didn't pick our color because of that. Yeah, and then, keep going down the line here. At T-minus 8 minutes, we'll start fuel pre-press. At some point, we'll do stage 2 TVC wiggles. I'm not sure if we'll be able to see those.
Those are tough to see, yeah.
Yeah, but they will happen. And then at T-minus 6 minutes, we will actually transition to internal power. So right now, Alpha is plugged into ground-side power, but in order to not drain the batteries. But when it comes time to launch, we'll actually, unplug the generator.
Yep.
Not really, but,
Gotcha.
Yeah, and then we'll be ready to send it. So that happens at T-minus 6 minutes. Not sure if we have a camera on them right now. Right now we're on the engines. But at T-minus 5 minutes and 45 seconds, you'll see what are called collar arms start to open. Hopefully you'll see it. It's a little foggy out there.
It's like a balance. Like, do we keep watching for the TVC wiggles here, or do we go show the collar arms? We have so many cameras, and it's a really good problem.
Oh, they are back. They're open right now.
They're the little clampy bits up at the top that you can see sort of pulled away from the rocket, right?
Yeah, so those are intended to stabilize Alpha in the high wind environments on the pad. So Vandenberg's super windy, yeah, and we don't want Alpha to undergo any non-required loading. So that's there to kind of support the structure while it's just kind of chilling out there on the pad.
This is why I like hanging out with engineers, because you're like, oh, it's not wind, it's non-required loading.
Ah, yes.
The wind is non-required loading. I like it.
You didn't have to call me out like that.
No, I love it. Like, it's fantastic. The strongback as well. At some point, we're going to see the strongback sort of pull out of the way to make room for the rocket.
Yeah, so you'll see that big structure on the back of Alpha. You'll see it pull back. And those umbilicals on camera will get a little bit more taut with the intent to separate from the vehicle when the vehicle actually lifts off. So yeah, it moves out of the way because Alpha's got places to go.
Alpha's got places to go.
She's got things to do. Yeah, and then T-minus 4 minutes we'll arm the FTS. So that's the flight termination system. It's required on every flight, every company. It's just kind of it's a requirement for safety.
Normal safety thing.
Normal safety thing.
That's the part that makes the rocket no longer be a rocket if need be.
Yes, exactly. That's how they hurt my structures, unfortunately.
Then we'll go up to some fuel bleeds, I think. We need to get some air out of the lines.
Yeah, so kind of the same story with the TVCs. We'll also bleed our fuel lines and make sure that there's no gas and any kind of undesirables in there.
Gotcha. All right, so the clock continues to tick here, folks. We're rapidly approaching T-minus 10 minutes. There's still a lot to talk about, but let's go ahead and cover what's... I'm still watching. Every time the engines come up, I watch to see if they're wiggling.
They're really exciting to watch.
And then it does this to us where it's like, you know, venting in the way. But we are... 5 minutes forward. We're getting there real quick. A lot of things are going to happen after liftoff as well. So let's talk about that because we want you to hear the sounds of the rocket. We want you to listen into mission control. We're not going to talk over the rocket noises. That's why we're sort of front-loading the explanations here. But what happens right around liftoff?
Yeah, so we actually let our engines at T-minus 2 seconds. Specifically our reavers.
Okay.
We'll let our reavers at T-minus 2. That's kind of to give them some time to spool up because we call, as a company, T0 when we actually release our mechanisms that's holding Alpha to the ground.
Gotcha.
And we start to lift off.
Okay, so it's not when the engines start, but it's when the rocket is released, then it's a separate vehicle that's ready to fly.
Yeah, exactly. So that's what we call T0. And then we'll be firing those reavers for several minutes. And during that time, we'll hit supersonic at around T plus 54 seconds. At T plus 1 minute and 5 seconds, we will hit max Q.
Gotcha. Max Q. So I hear this all the time. Max Q is, of course, maximum aerodynamic pressure.
Yes.
But everybody has comments, and they love to share them with people, especially online. And some people are like, oh, max Q, it's not really that important. Y'all just make a big deal of it.
Oh.
I have the structures person on the stream with me. Max Q, important or not?
Max Q is very important. It hurts my heart that people say it's not important. Max Q is this weird moment where it's different between rockets and airplanes. But for a rocket, it is where we are going faster and faster and accelerating out of the atmosphere. But the atmosphere is getting thinner and thinner.
Right.
So it's this crossing point between static and dynamic pressure. It imparts the strongest loading and the stress on the vehicle that it will see at any point during flight.
Gotcha.
So I'm biased as a structures person, but yes, max Q is very important. We size the rocket to max Q.
Right.
So it has to be strong enough to handle that point of maximum loading, but not be so strong that it handles way beyond that point, because then it'll be super heavy.
You don't overbuild it, and then you have too much rocket on your rocket,
Too
and then
much
you
rocket.
lose payload, you lose capability, all that sort of stuff.
Exactly.
So a fine balance there. But moving along, the engines are going to continue to fire. Max Q, which is very important to structures engineers,
Very important.
will happen, and then we get up to main engine cutoff, right?
Yeah, so we'll hit MECO at T plus 2 minutes and 30 seconds, and then a lot happens in like 15 seconds. So very shortly after MECO, we'll have our stage separation. You'll see stage 2 kind of float a little bit and stage 1 fall away.
Right.
And then you'll see stage 2 ignition. So we'll actually light the candle on our lightning engine.
Lightning engine.
And that will start to pull away. And then very shortly after that, you'll see fairing jettison.
Gotcha. Oh. Well, this is actually the lightning engine that's on the
stage
camera
2.
right now.
Yeah, that's the nozzle extension.
Excellent. So we might actually see this happening because we were
some
talking
wiggles.
about the wiggles.
Yeah, I don't know if we actually saw stage 1 wiggles, but the stage 2 the stage 2 wiggles are not as big.
Yeah, I want to like believe, like we're looking through some lights. I want to believe that it wiggled there, but unfortunately we can't sit here and just watch. Chat, y'all help us watch this while we continue to talk. So we'll get through the fairing jettison. That is an intentional thing. Again, we don't need the fairings anymore at that point.
Yeah, so what we're doing by fairing jettison is the fairings have done their job by this point. They've protected the payload through launch. And we don't need the mass anymore. It's very expensive to take mass to space.
Right.
So we eject them and we continue on without them.
Gotcha. So that is a perfectly nominal thing to get rid of that mass. They've done their job. They protected the payload from the payload facility over to the rocket. They protected it during launch through its flight through the atmosphere. And now they've done their job. The atmosphere has thinned out, and we can go ahead and expose the payloads to, well, the vacuum of space, basically.
Yeah, there's no need for any more moisture control or anything like that. They're good to go.
Makes good sense. And then we're going to have a big coast phase today. What are we, like almost a 36-minute coast phase, I believe, right?
Yeah, so we'll finish firing our lightning engine at T plus 8 minutes and 10 seconds. So we'll hit SECO, which is second engine cutoff.
Yep.
And then, like you said, I think it's a 36 or so minute coast phase for that stage 2, just kind of going around Earth until we hit the speed and the height that the payloads are going to be deployed at.
Where they're going to do their missions, because you're delivering them right to that orbit today.
Yes.
Today?
Tonight, tomorrow, maybe?
Y'all know what we mean. And that brings us all the way up. The last payload expected to be deployed just after T plus 55 minutes there.
Yeah.
So how are we doing on the clock? 5 minutes. just over 5 minutes. Actually, 5 minutes and 40-something seconds there. Is the rocket getting less visible?
Unfortunately, I don't think Locke's bleed is helping, to be honest.
The rocket's actually contributing to the environment here.
Yeah.
So, look at this. We're actually going to have a little bit of a reaction cam. These are some Fireflies here in Austin watching nearby, right?
Yeah, they're not too far down the road. Yep, there they go.
They know they're online. Nice. They must be there. There's a big screen, and they're displaying the mission. I guess they're displaying us to everybody there at the company.
Ooh, don't tell me that.
But those are all the folks who work together to make the rocket happen.
Yeah, those are all of the awesome ladies and gents that make this thing fly.
Outstanding. We'll see if we get a reaction cam there after the mission gets going. But it looks... We'll go back to the rocket here that we can't quite see, having just crossed under T-minus 5 minutes. So let's set some expectations. It's a long coast phase. We do anticipate staying live because we believe we'll have... Oh, nice. The strongback is retracted.
The strongback is pulled back.
Excellent.
That looks a lot less foggy from that angle.
Yeah, those close-up cameras really do help. We do plan on staying live through the entire coast phase. We've got some other stuff to share with you. We'll be answering some audience questions. We'll talk about some of the NASA payloads that are on this mission, and we're also going to talk about Firefly's upcoming mission to the moon. But the real important thing, like, you don't just see the launch and say, okay, we're done, shut down the stream, because we do expect to have live video of some of the payloads deploying that we've been cleared to share with you if it makes it down through the ground station. So that's going to be the plan coming up. We're rapidly approaching T-minus 3 minutes here, but Morgan, really quickly, an audience question.
Sure.
Have you been on console for a test, for a launch? What's it like?
Yes. I really wish I had data in front of me right now.
She just wants to talk about the data. I love it.
I really want the data. I need my emotional support strain gauges. I'm very sad I don't have them. But yeah, I have sat console. It's a really weird feeling because you know, cry and bleed and sweat all over these things for months.
Right.
And then when it's time for them to go, it's you're sitting there behind the computer staring at the data that you've been staring at from all of the tests leading up to this, and you've prepared this thing as much as you can, but you're still nervous because, I mean, how could you not be?
Yeah.
Right? This thing's about to go. It's not going to be on the ground anymore. And then when it is let go, you can't exactly kind of pull it back. So yeah, it's a weird blend of stress, but relief and pride, and all in all, just an emotional roller coaster.
Good deal. But you've designed the rocket to be able to handle this.
Exactly, yeah.
All right. We will send it on its way because now we're under T-minus 3 minutes, y'all. We're coming up on the final poll. Any second now, we're going to listen into the launch conductor, who's going to be asking for a go, no-go from the chief engineer, the launch director, and the range operations commander. So we are going to listen in. I don't want to talk over them. I know how you feel when we talk over folks that are doing polls, but we expect that coming up any second now. Don't know exactly when that's going to happen, but this is the last critical sort of human step, I guess, to confirm that we're ready to go. Let's just go ahead and listen in to mission control here.
T-minus 2 minutes. This is the final commit for launch. Chief engineer.
Chief engineers, go for launch.
Launch director.
LD is go for flight 5.
Rock.
Rock, range green.
We are go for launch.
There you heard it, folks. We've got 3 green buttons on the screen there, 3 green lights. Chief engineer, launch director, and the range ops commander all go for launch, now less than 90 seconds away, a minute and a half, folks. So here's the plan. We're going to let you listen in to the sounds from the pad. Just tune right into the noise of summer from the rocket launch. I guess the noise of summer here is the rocket launch itself. We'll let you listen to the launch net. We'll let you listen to the sounds, the venting and stuff from the pad. And we're going to do our very best to be quiet, but we are coming up on 1 minute.
T-minus 60 seconds.
Acknowledging helium. Acknowledging air rag.
To lose pressure, it's coming up.
T-minus 30 seconds. Alpha is transitioning to autonomous mode.
Normal stage 1 TVC motion.
T-minus 10, 9, 8, abort.
Elsie, go ahead and start your safing operations.
Copy, we're starting safing operations.
Working for shutdown.
Please confirm no fires on video.
I see no fires on video.
Copy, please turn off roll purge. GC.
Roll purge closed.
Verifying blue lines. BC, please confirm C-RIO is in the latch state and command it to release safe. Copy.
That motion is actually the strong
Can you
back
verify
going
we're in
back.
manual state?
Yeah, it does
Eagle
look like
FSW.
Alpha's tipping over from that angle, but I promise you it's not.
Count auto sequence is completed.
Confirm we're in manual.
Copy. City 1, release system is now safe. Yes, go ahead. FTS, can you confirm you said brake wire signals have not gone high?
FTS confirms he said brake wires have not gone high.
FTS, please confirm these sides are safed.
I can go ahead and save them now via 1441.
Copy, please run alpha power external. BCG confirming running alpha power external.
And the collar has reclamped as well there.
BC, please run alpha power external.
So we're
Copy.
continuing to listen in to the launch net there. As you can see, there was
Copy.
a hold right before liftoff. We do have
verify
a
height as the
30-minute
auto
window
interval.
here, and right now we are waiting. Right now we're waiting
Verify.
to see if we can recycle within those 30 minutes. So we're going to continually. It's really tough not to talk over them, but I don't want to.
Yeah, it is difficult.
We're going to continue listening in, and we'll provide an update as soon as we can.
Elsie on CD1, we're going to try for that last window we didn't get moving.
Copy. GC, if we could trigger up on S1, S2 lock stopping.
Good copy.
BC, can we verify NV161 Charlie is closed? Closing. You can verify open NV235 Bravo. And close A2 SVNN. And then close NV spin vent.
Copy.
All right, folks, you can see on the screen that hold up there. We still don't have any information on the abort. We're still trying to see if we can recycle. Again, there was a 30-minute window here, and we were targeting the beginning of that window. So we've got a little bit of time, but we're waiting to get information on what the next steps are.
On someone going back to umbilical.
On CD1, go, no go for recycle ops will be in 1 minute.
We're continuing to stand by, but the best source of information is the launch net there. So we're just going to keep listening. That's why we're being quiet, so y'all can hear what's being said.
This is the launch conductor on count.net with the readiness report for recycle operations. For us, we are still investigating the issue, but to get us positioned for an additional attempt, we're going to step back into recycle.
Alcon for awareness on CD1. We aborted on a ground side helium high, so at 7 seconds we aborted on HPD 201 and 211 averages. At second stage cryogenic helium loop, we are investigating the cause of those. They should have vented. While we investigate that, we're going to go ahead and try and recycle.
On CD1, this is the poll for recycle operations. RC.
Go.
FSW.
Go.
GSW.
Go.
GNC.
Go.
Fluids 1. Prop 1.
Go.
AVI.
Go.
FTS.
Go.
FISPO.
Go.
FCO. Mission Manager.
Go.
Safety Official. OSM.
Go.
Chief Engineer.
Go for recycle.
Mission Director. Launch Director.
Go.
Safety Official.
Mrs. Misko, go.
Copy. Fluids 1.
We're going to need to load some more fuel on stage 1, but we will be a go.
Copy.
Alarms are in loading.
So a bit of translation, sounds like they were getting the rocket into a situation, a position that they can go for the end of the window if they get that clearance.
This is Battery
CEO
3 on CD1 to LC, requesting to go to 2 pump for circulation on the second stage. Helium.
Copy.
SG craft is triggered up.
So a bit of an update here, y'all. It sounds like they are going to go for the recycle here. Again, it was a 30-minute window we had. With that hold right there before launch, we had almost the entire 30-minute window remaining. We're currently just around 9 minutes into it. So it looks like they are continuing to get the rocket ready again to see if they can't hit the end of the window. Don't have any details to share on exactly why it happened, but they look like they are getting ready to give it another shot.
LDRC countdown 1.
And we've got an update on the clock here now. You can see the clock is now counting down from T-minus 19 minutes, which makes it look like they're going for the very end of the window, which would make it 9:33 p.m. Pacific time. I like the fact that the hold has been cleared off the screen as well.
It's movie magic right there.
Again, folks, if you're just joining us, here's your update. We counted down to just within a few seconds of the initial T0, 9:03, but there was a hold. And what's happened, we had a bit of a launch window this evening, 30 minutes to get the rocket off the ground. Teams were reviewing the data there, and it looks like they are going for a recycle here and now targeting the very end of the window, which is going to come up in T-minus 18 minutes.
RP1 storage alarm.
Alcon on countdown 1. The clock is rolling. T-minus 18 minutes.
Copy. Go no go poll will be in 1 minute for terminal count.
Again, y'all, right now the best source of information is the LaunchNet, so we are going to continue listening in. Sound like there might be another poll coming up here in a second, but best thing to do is keep your ears open and your eyes on the rocket, I guess, but it's Vandenberg.
181, this is Launch Conductor, Countdown Net with a ready report for terminal count, RC.
Go.
FSW.
Go.
GSW.
Go.
GNC.
Go.
Prop 1.
Go.
Fluids 1.
Go.
Structures.
Go.
AVI.
Go.
FTS.
Go.
GC.
Go.
BC.
Go.
Payload.
Go.
Mission Manager.
Go.
LWO.
Go.
ISPO.
Go.
IFCO.
Go.
OSM.
Go.
ROC.
Go.
Safety Official.
Go.
Chief Engineer.
Go for terminal count.
Launch Director.
Go.
Go for terminal count. Copy, go ahead.
Water deluge pump alarm. Expected.
LDA, this is RC on countdown 1. You can confirm you're good to go.
LD or LDA, over.
Looking for the LDA concurrence to proceed.
This is Firefly Safety Official on CD1 net. Flight termination receiver checks per procedure 1441 recycle sections are complete. All ESATs armed properly and maintain firing voltage. No anomalies.
BC, please run the terminal count auto sequence.
First selection server is changing. Minor data lags are expected. Moving to 44 Alpha.
GC, please pop out your FireX display safety tab.
Copy.
As a reminder on CD1, in case of anomaly, please say abort, abort, abort on CD1. VC here and abort, please abort the auto sequence. Copy. Clock is synced.
All right, folks, got some more information to share. It sounds like the hold there right before liftoff was due to some ground support equipment. And it sounds like they believe that they can continue on here with targeting the end of the window now just around T-minus 14 minutes. Again, we're targeting 9:33, which is 30 minutes after the original launch window there, as a second opportunity to get Alpha Flight 5 Noise of Summer off the ground this evening.
S1 logs max feed level.
T-minus 13 minutes. FSW, please start a Wireshark capture on local port PCAP server.
Started.
T-minus 12 minutes.
All right, to reiterate, you see the clock continuing to count down, and they are targeting that 9:33 p.m. local time, T0.
Launch terminal count.
As a reminder, in the event of abort, we will perform the following actions. Confirm there are no fires around the engines, utilizing fire exit called out by LD. If there are no fires, GC will turn off roll purge. We will then confirm vehicle health, pre-valves are closed, helium bubbler is active, S1 fuel tank is maintaining between 30 and 36 psi, so it is A1 PFTs. We will then verify other vehicle tanks are vented. We will then step into verifying ground side health, verifying T-TEP tank is vented, TVC tank is vented, spin system is vented, cavity purges are active, and strong bank has re-engaged. We'll confirm with range we're okay to disarm and power down ESATs, and we will power off Stage 1 and Stage 2 FTS. We will transition to manual power. We'll then clear avionics, FSW, error codes. Auto is aborting.
Stereo.
Stereo.
Stereo alarm.
LC, start safing operations, please.
Good copy. Please verify no fires.
There are no fires.
Copy. GC, please de-energize roll purge.
Roll purge closed. Alerting
Good
stereo
copy.
alarm.
Copy. Blue lines are confirmed. BC, please confirm the CRIO is in the latch state and command it to release state. Copy. Can you confirm that we are in manual mode? Copy. Release system is now safe. FTS, can we verify ESAT brake wires have not gone high?
Brake wires have not gone high.
Copy that. All ESATs are safe. BC, please run alpha power external. Copy.
Stopped. Confirm.
On CD1, we had a failed check in terminal count on release RIO control status. This is the launch conductor on countdown.net with a readiness report for entering scrubbing operations. RC.
Go.
FSW.
Go.
GSW.
Go.
GNC.
Go.
Fluids 1.
Go.
Prop 1.
Go.
ABI.
Go.
FTS.
Go.
ISPO.
Go.
IFCO.
Go.
Mission Manager.
Go.
Safety Official.
Go.
OSM.
Go.
Chief Engineer.
Go.
Launch Director.
I am go for offload, but would like to further investigate the helium
Good copy.
options during that offload period.
Good copy. DC, if we could cycle WV502 to relieve deluge pressure. And verify pumps are off. GC, please cycle WV502.
Copy.
Open.
Can we open with WV502?
Copy.
All right, y'all. We've all been listening in to CD1 there, to the launch net, and we're all informed that today's Alpha launch has been scrubbed due to an issue with the ground release equipment. So a lot of things still going on. We've been letting you listen in. Morgan, what do the next steps look like here?
Yeah, so unfortunately this is just part of the game.
Yep.
So right now the team's going to work with the range and with our NASA customer to determine the next available window for launch. And our ground support team will assess the situation on the pad and will work to resolve the issue so we can launch as soon as we can.
Gotcha. All right. So again, if you're listening in, the current information is that Alpha's Flight 5 has been scrubbed for the day. Now, we are going to keep you informed with what's going on, including details on when the next launch date might be. Make sure you're following along on social media. It's Firefly_space over there. X, Twitter, whichever way you want to call it. Now, that is going to conclude today's broadcast coverage of the Flight 5 attempt. Morgan, thank you so much for joining me.
Yeah, well, thank you for having me, and I'll see you again when we try this again.
All right, sounds good. Folks, thank you for watching as well. This is how it goes. You know the saying, you'd rather be on the ground wishing you were flying than flying wishing you were on the ground, and that's where we are right now. So we do appreciate you watching. Stay tuned to social media, and we will see you later.
Release system is armed.
Vehicle is transitioned to autonomous mode. We are go for launch. 3, 2, 1. Ascent operations will continue on CD1.
T+1 minute. Max Q.
We go. Stage separation.
Bearing separation confirmed.